Next keynote is Gary Adams, who's Senior Director of Marketing for Silicon Motion. He leads a focus team in defining and promoting enterprise controllers and development platforms that accelerate high-performance data center SSD development. Gary has over 20 years of experience providing innovative leadership in storage products, business solutions addressing market applications and needs. He has various marketing and sales management position experience from a wide range of storage memory component companies, and he earned his bachelor's and master's in electrical engineering at Cal State Chico University. Any of you been to Chico? It's one of the most beautiful places in Northern California. It's a beautiful campus. I've been there several times, and I'd like to welcome all of you to Gary Adams.
Thank you. Well, welcome to the Silicon Motion keynote presentation. It is an absolute pleasure to be back at FMS after a little hiatus. I think if I look at my personal experience back, it was amazing to see all the friends go, look at this. We haven't seen you in 2 years, and why didn't you call, right? So this is, Silicon Motion has been attending Flash Memory Summit for approximately the last 10 years, but this is the first time that we're participating in a keynote. And the reason is over the last few years, we've been working to understand the incredible challenges in developing data center SSDs and how we can accelerate the innovation in our customer solutions. So this is the required squint slide. I'll give you a moment. All right. Before we get started, we thought we'd share a little bit about Silicon Motion for those that are not familiar with us or our products or our businesses. We are a global leader in supplying NAND flash controllers for solid-state devices. And since 2004, we've shipped 10 billion NAND controllers into the storage market. From our first shipments in compact flash controllers, SMI has continued to provide innovative products for SD cards, USB flash drives, and embedded memory controllers. Starting in 2007, we started shipping our first SSD controllers, and we supply more SSD controllers than any other company in the world for servers, PCs, and other client devices. Our customers include all the NAND flash suppliers, and we are a merchant market leader in controllers for eMMC, UFS mobile storage used in smartphones and IoT, and other applications. We also supply custom high-performance data center, specialized industrial and automotive SSD solutions. So the net is we're about a third of all market NAND controller shipments, and we outship our largest competitor from 4-1 in the space. We're established leader and are recognized by our OEM customers to provide best-in-class technology and continuing to provide innovation. Okay, so in conclusion, from an SMI understanding perspective, it is likely today that in your digital experience at FMS that your digital experience went through an SMI NAND controller. Okay, so let's get to the discussion here. So what we've been looking at is technology transitions and their challenge that present us in SSD design. From our point of view, like anyone else, challenges really give us the opportunity for SSD innovation. We look at 4 things that are kind of giving us the idea of areas that we need to look at very specifically. One is the changes in the acceleration of interface speeds, PCI Express today, and many announcements around CXL. We're also looking at NAND technology transitions, the increased layer count and need for multi-everything that through a NAND, and the transition from TLC, QLC, and then PLC, and the constant evolution of standards and customer-specific requirements. And lastly, what we hear every time we come to a show like this is how do we do application optimization methods for improved performance in QoS. So with the acceleration in these market transitions, it's clear that we need to focus on innovations with SSDs, both from SSD design, but also in our business models that we engage with others. So let's get to the PCI Express transitions. I think we kind of enjoyed a very long gap between PCI Express Gen 3 to Gen 4. It was relatively slow and easy to absorb. However, the transition from PCI Express Gen 4 to Gen 5 was really quick. And now, we have PCI Express Gen 6 around the corner, and now they're defining PCI Express Gen 7. So what we need to do is critically look at scaling internal SSD resources and the impact on power and components as we kind of go through this mantra of increasing interface speeds. And for a high-performance SSD design, when we look from a SSD perspective, we want to make sure that we're focusing on maximizing the interface bandwidth, ensuring that all system design elements are used to maximize that SSD performance. So what do? We look at the CPU resources. We need to ensure that we have and can support enough of the random IOPS performance. In addition, we have to scale the DDR interface bandwidth to a point where it matches the PCI Express interface as well, and still contain all the elements and optimizations that we need. In addition, we now have to look at encryption and line rate encryption and decryption on the fly. And all this increased performance has to be achieved with power scaling in mind. The appropriate power at the right capacity on the right form factor at the right time. So beyond general connectivity, now let's look at the NAND technologies. We have to consider larger block sizes, the decreases in geometries that cause us to my script just fell off. Okay. So we have to look at the what's defined as next. We have to look at the improvements in LDPC engine technology to match the rates that we have. Thank you. And the right approaches are for. It's moving again. Speeds up support hard code to be able to support multiple NAND types. As a side effect of larger NAND sizes, the SSDs must balance simultaneously what we see from multi-plane operations and the number of die placements that we do in the SSD to achieve effective performance. And this will impact power loss protection and total power circuitry within our SSD. We have observed, and even mentioned the previous speaker, the introduction of machine learning technologies. And when we look at the transition from TLC to QLC, it presents new challenges on multi-pass programming models and management algorithms. Having a programmable and flexible flash channel controller is required for these transitions. Standards. Where do we start? Standardization and open specifications are critical to reach market adoption. I think we all agree. But what's kind of comical and arguably challenging is when you look at even the SNIA classifications for NVMe SSDs, it becomes very complex and even harder to when you want to explain to someone else. In other areas of standardization, we've seen the NVMe group do very, very well on NVMe 2.0, providing like hierarchy for memory structures, as well as providing the superhighway for rapid spec adoption. So no longer do we have to wait for an NVMe spec to go through a full evolution. We can rapidly go from a technical proposal to specification. Examples of this have been in some of the most innovations around ZNS, as well as a key per IO specifications. In addition, we see continued adoption of security with advanced security features like platform resilience and boot and attestation. And we anticipate that we'll continue to see these type of standardizations as we move forward. So we need to define the firmware of everything in our architecture so that we have such a flexible ASIC architecture that firmware is able to be adopted and be flexible. And then the appropriate level and use of hardware accelerators to align to this ever-changing landscape. The NVMe SSDs, when we get to now moving on to application awareness, I think NVMe SSDs where it's simple plug and play, right? You just kind of put them in there, you're replacing your HDD technology, and the end user doesn't really need to be aware of what's happening with the NAND. What is the NAND, and how do we place things in the NAND? However, when you're application aware, we start seeing some interesting things happening. And a user can start looking at how do you use the controller resources, as well as how would you manage the way the data is placed, and how it is cleaned up within the media so that we can optimize application performance or endurance of the SSD. The industry continues to look for opportunities for application optimization. We've seen different methods, both from standard NVMe as well as host-based FTL user models. And examples of these on our slide, I would say multi-stream writes was one of the first examples where we could do some isolation within the controller. Open channel SSDs had their life over the last few years, and SMI is one that provides open channel SSDs in production. Also, the introduction of zone namespace drives and the continued work in this space, which SMI supports, and as well as software-enabled flash that continues to gain momentum, and then other new technologies around data, direct data placement, or flexible data placement. However, the increasing SSD capacities make many systems need to support multi-tenancy to have full SSD utilization. And the challenge is how do we properly isolate the ASIC resources to eliminate the noisy neighbor problem. So new solutions need to be created to maximize SSD performance while achieving the total overall performance goals that you may have for a single or multi-tenants that use the same resources. So Silicon Motion recognized early in our development that SSD controllers with just reference design firmware weren't enough to address this continuous innovation that we see in these areas. So we had to work kind of with purpose-built firmware, ASIC and hardware that could work synergistically from the beginning of the development to meet customer needs. So at FMS this week, we are introducing our MonTitan PCI Express Gen 5 SSD controller. It includes the SSD controller ASIC, standard-based firmware design kits that support all the EDSF form factors, as well as the legacy ones, and a layered firmware stack for both standard NVMe and host-based FTL usage models. So starting with our controller, the MonTitan controller for high performance is Gen 5x4. It supports 16 channels running at 2400 megatransfers, provides industry-leading blazing performance, and we were successful at putting into a small form factor, 21 by 21 square package, so that it could fit in all the standard new EDSF form factors. For the MonTitan platform had a lot of interesting things going on as you start reading, but what we wanted to do was focus on 3 technologies that kind of address these challenges that we have today. And one of them is performance shaping, which addresses in hardware, ASIC, to be able to provide the appropriate ASIC resources perspective to tackle the multi-tenant environment problem. We wanted to highlight NAND command that maximizes the use of the enterprise NAND in enterprise SSDs, and as well as innovation on our go-to-market strategy in using layered firmware stack to help our customers develop and get to market faster. When we started looking at the controller architectures, we thought it was good from an individual block elements to see how they relate to each other, and then start isolating them so that they didn't poison each other when we were trying to maximize performance. And once we got there, we started thinking, well, if we can start even additionally isolating these elements more, then maybe what we can do is start tackling the multi-tenant problem. And that's what we've done with Performance Shape. It was born out of these studies, and is an ASIC accelerated performance shaping mechanism to optimize our SSDs on a per defined QoS set. Combined with the hardware isolation of the technology, our 8366 provides maximum bandwidth of the entire SSD while still being able to be focused on each tenant's QoS type, which may be latency, the read-write mix of IOs, or the total read and write performance. Performance shape will enable our performance goals and a utilization of SSD resources, and we're still looking for creative ways that we can extend the technologies further. NAND Command contains a high-speed LDPC engine technology with higher correction capability. It also combines efficient media tracking and management and an optimized data path for small latency and high throughput. We identified the need in this generation of controller to be able to have it exceedingly programmable and flexible at the single flash channel level and be able to support very fine granularity of mix and read-write tuning. And that was a functional focus for us. The other thing we did architecturally to look at the product was to make sure that we could support the very highest performance NANDs, to do this from both 4 to 8 plane operations per LUN, and providing independent plane and unique queue to realize non-blocking access for ideal latency within the controller. Special care was given to the level of performance required for multipass programming models. So, in combination of machine learning and smart management and DSP engines, we're able to respond and enhance media monitoring and error recovery of the entire SSD. And lastly, our LDPC engine is capable of managing all these functions under the umbrella while still achieving our customers' Uber rates. So, lastly, what I wanted to talk about is a go-to-market innovation that we want to provide, where traditional controllers models in support have kind of been in two different camps. You provide a turnkey firmware stack in the controller, and you work collaboratively with your ASIC supplier, and the ASIC supplier does much of the firmware enhancements. This is really good from a time-to-market perspective, and the end customers do not have to do a significant amount of estimate from a firmware resource perspective. At the same time, that it doesn't allow for a lot of market differentiation. The other alternative is that you provide the controller and a software development kit, and then the onus is on the actual end customer to go and hire the firmware team, become experts in using the ASIC, and then over enough time you can develop a good and reliable product. The problem with this, as we've just been describing, is the market transitions are occurring so quickly. To be able to do this on a quick turn, even over a couple of years, is becoming very daunting, right? So what we're trying to be is more innovative, and what we'll be providing is our layered firmware stack that is modular, and it will allow the user to provide fast and efficient firmware development because it'll be licensable. And then because it's modular, as described on their slide, it'll divide and conquer the firmware development in combination with our customers, and it'll be optimized interface for customizations. So what are some of the specifics? If we look at our stack on our slide, first thing we do is we try to do a hardware abstraction from the actual underlying metal of the controller. So basically what our customers' firmware and our own turnkey firmware will be doing direct API calls. And when a customer is using our controller, they do not need to understand when they're designing the firmware all the expertise, underlying requirements, and how it works. It'll be all controlled by API. We also have a common FTL layer that will maximize reuse across all FTL types. And then we'll have a NAND flash adapter layer supporting all the NAND models for different vendors. We have reusable firmware models for those that are kind of consistent within the industry for management, controlling diagnostics. And we'll have a customer customization layer that sits on top of that. So if we only want small changes in our turnkey stack, a customer can change these SSD parameters on the fly, and you can add your own specific applications. This innovative approach, we really hope that will reduce the time to market for our end customers and still provide them the ability to provide differentiated solutions with less of a firmware investment from the customer. So, in summary, we continue to be looking at the exploding environment of technology transitions and lead the design challenges. Silicon Motion views these as opportunities to work with our customers on the MonTitan PCI Express Gen 5 development platform, and we look forward to working with our partners and our customers on these solutions to the market by enabling acceleration in the market. So that's the end of my presentation. If you want to learn more about our product, you can visit us at the booth number 301 or explore us in the insights at the FMS forum. Thank you.